Welcome to the National Math and Science Initiative's Video Professional Development Series for teachers of AP Physics 2. This is Module 1 Electrostatics, Part B. We're going to talk about electric fields and potentials. My name is John Frensley. I teach at Prosper High School in Prosper, Texas. Now, let's talk about what students need to be able to do. This is not everything that students need to be able to do. This is just selected things students need to be able to do. So this is not everything that I'm going to talk about in this video. Students got to be able to describe what static electricity is. They got to represent static electric charges or net charges on conductors and insulators. That basically means drawing little pluses and minuses on diagrams that show where the charges are in balance, right? Remember, every object has a whole bunch of positives and negatives. But if there are more positives and negatives, we're going to draw little pluses. If there are more negatives than positives, we're going to draw some little minuses there. They need to explain how to charge conductors or insulators by contact or through induction. Students also need to understand the difference between what charges do on conductors and insulators, so that's going to be important. Now, let me just tell you right now, there's a bajillion static electricity experiments on the internet, and there's no static electricity experiment that is too elementary or low level. I would strongly encourage you to take 2 45-minute classes or a 90-minute block and just do all kinds of static electricity. It shows up on the exam like crazy. So go do your research, just go find lots and lots of things that students can do with static electricity. A Van de Graaff generator would be great. I would want you to get one. The school I'm at right now has a hand crank Van de Graaff. It works, but we have so much humidity. This is the beginning of October in North Texas. It's very humid out here. It's very difficult to get anything to happen. Look for static electricity activities with a Van de Graaff generator or some other kind of terms, and find activities that are appropriate for high school students, but even activities. Here's how you know that it's appropriate for AP Physics 2, even if it's labeled as junior high or something like that. If you can have the students draw a diagram and draw the pluses and minuses for what charges are being induced or whatever conducted, and if you can have students explain in words what's going on. This substance is removing electrons from that substance, especially if they tie everything back to electric force. What do you observe that tells you that these are opposite or same charges? And conservation of charge. How do you know that the net charge before your charging process is equal to the net charge after? Or if it's not, where did the net charge come from or go to? So please don't look if the label says this is for 8th graders. It may be something that you can modify for your kids in high school, just as long as they're drawing diagrams and making up. Go with claim evidence reasoning, CER. If you can find a bunch of things you can do CER on, then it's high school level automatically, in my opinion. You can look online for static electricity activities that involve more common items if you don't have a Van de Graaff generator. Balloons, PVC pipe, glass, styrofoam, wool, fur, silk, those are kind of things you can get a hold of pretty easily. Have them perform certain charging process, have the students explain in words what's happening, draw pictures showing the plus and minus signs, and make sure that they're saying things like, here's what I observe, here's what I claim. My claim is that the charges, the pluses are here and the minuses are here. Here's my evidence, here's what I've observed, that kind of stuff. Go with CER for these kind of things, I would say. Okay, so students may have to do some research to know whether the charges are positive or negative in a given case. There is no way to just have materials in front of you and know which charges are positive or which are negative. The best thing I can do is to know that when two objects repel, they're opposite sign charge, or like sign charges if they repel, and then they're opposite sign charges if they attract. That's the best you can do at this point. So you may have to have students find out, if you rub the glass rod with the rabbit fur, which one's positive or negative. Have them do that. Have them do CER to connect what they observe to what they know about the signs of charge and that kind of thing. Okay, I would have students build an electroscope. Like a lot of teachers and a lot of labs have an electroscope. I would have your students build one, and I wouldn't tell them how to do it. I would tell them to go on the internet, research ways to build an electroscope, and I would tell them if you have to buy anything really special like copper wire, you need to do more research, because you can build an electroscope with a bottle or jar, an index card, some tape, and a paper clip and some foil. So you shouldn't have to buy anything, honestly. Use the electroscope as part of your static electricity lesson days. So I assign the electroscope in advance. The students bring it in on the day we do static electricity, and we use it as part of our experiments. Make sure they explain how the electroscope works, making a diagram, drawing pictures, and that kind of thing. Electroscope has shown up on the AP Physics 2 exam. Okay, now, the other thing I'd like to talk to you about, so there's really three things in this video. Applying Coulomb's law to a situation involving two charges, and the AP exam loves to have students compare the Coulomb force and the gravitational force, and also to discuss energy changes related to charged objects. So what I'm about to do now is I'm going to do an activity. It's a whole class activity. You can have the students do it in pairs, but my stars, this is so difficult to get it to work really well. We're going to take two identical balloons. We're going to fill them up with about the same amount of air. So when I fill them up, I just take the biggest breath I can and let it all out. Maybe do that 4 times, make a big balloon, all right, on both of them. So I have about the same amount of air. We're going to attach the balloons to equal length strings. We're going to connect the free ends of the strings to some point on the ceiling. We're going to charge up the balloons using some process. What I'm going to do is I'm going to rub the balloons against the Graaff generator while it's on. And let's try to give them equal charges too. And the balloons should hang but not touch each other. And what we're going to measure, and you can measure the mass of the balloon before you blow it up, the length L, and that's not just the length of the string, that's the length between the ceiling and the center of a balloon. Again, I would measure that before I even hung up or charged the balloons. And then this is what you really want to get. D is the center to center distance between the balloons, or, and I think that's easier to get, but harder to get, is theta, the angle between the balloon string and the vertical. Now, if you get one, you know the other, because you can take half of D over L, and that is the sine of theta, or the sine of theta is equal to half of D over L, and you get the idea. You draw a diagram, and you can do trig to relate this, and theta. So you really only need to know 2 of them. Okay, so I'm going to go and try this balloon thing out, and let me just tell you right now, this is really tough to do. You really got to practice, and it better be a dry day. I have some data that I've taken from a previous time I've done this with students. I'm going to show you how to do it, but I've already worked it out with the data I had before, so I'm just going to tell you a secret. I'm going to set it up for you, show you what it looks like, but I've already got data for it. So let's see if I can make this work.